What is a vector?
Something that has both magnitude and direction.
Okay, we can go watch Despicable Me if we really wanted the same definition, but more entertaining. But yes,
Did we do that?
yes, vectors have magnitude and direction. Okay? Huh? Oh, you're quoting. Okay. So here is vector A, B. We have an initial point. We have a terminal point. The arrow is at the terminal point. Okay. We call this vector AB. You will notice that vectors will sometimes be named by single letters, and those single letters are italicized and bolded. Okay. The length is notated by those double bars. Okay. And what do we call the length? Its magnitude, okay. The direction is basically the angle from the positive x-axis. Okay. It's all coming back to us, right? Okay, vectors are equal if they have the same length and the same direction. Okay, sometimes we will think about slope, since we are talking about calculus, okay, for direction. But we have to have the same length and the same direction. What if they have this, I guess, what would we consider parallel vectors?
Same direction for length or different.
Same direction, length doesn't matter. Or what other kind of direction? Or opposite direction. Okay, that'll be important here in a little bit. But parallel vectors we would consider to have the same or opposite direction. We're going to refer to our vectors in standard position, which means their initial point is at the origin. There are different ways to write a vector. The first is component form. If our vector is not in standard position, then we take terminal minus initial to get the components of our vector. Notice how that V is bolded? That's because it's a vector. V for vector. And then if it's in component form, you have those chevrons instead of like parentheses for coordinates. Now you work with vectors in physics, right?
Yeah.
Physics 1 and physics 2?
Well, it's really just like vectorization. It's not so much the calculus.
Obviously, yes, because not everyone's in calculus.
Yeah.
Yeah. But today we're barely going to use calculus.
Very well.
We're going to use calculus once today.
Like it when we explain it in terms of calculus.
Huh?
Yeah, we always
He
get
doesn't like
Marshall
class.
class.
He doesn't like when you give your answer in terms of calculus.
He doesn't?
He's like, this is algebra different based. You cut this out of it.
Yeah,
I tried to answer it.
Doesn't calculus make our life easier?
Calculus doesn't.
Yesterday in the quiz bowl, I think there were like 4 or 5 times where calculus made the problem way easier to solve than algebra.
Counter in everyday life.
Thank you, Tyler. Just talking about reason
Does the
efficiency.
quiz will count as everyday life?
That's for me.
Or
It
Tyler,
does
yeah.
to Tyler. Okay, two vectors are equal if they have. I wanted to really emphasize that. Okay, the magnitude of a vector is basically the Pythagorean theorem. How long is that hypotenuse? If you draw the horizontal component and the vertical component, then the vector becomes the hypotenuse. Okay, so square root of horizontal component squared plus vertical component squared.
subscripts and superscripts at the same
Oh,
time.
wait. Okay, so this is the component form is vector h1 point minus initial point.
Where the vector starts and where the vector ends. So this is the initial point, this is the terminal point.
Yeah. And then you subtract from step 1.
Or this.
Oh.
Thank you. No, that is not a vector. We're not going to describe them quite like that.
I know. That's how.
I know. I don't like the. I don't like.
You're not alone. We triggered for all of us.
What do you need, Josh?
Never mind, I probably have all these notes out.
Okay, here's a vector PQ. It begins at negative 3, 4. It ends at negative 5, 2. Sean, please describe to me how to find the component form of this vector.
The change in x and the change in y.
Okay, what's the change in x?
-2.
Okay, and y?
Also -2.
Okay, so the component form is -2, -2. Subtract the x's, subtract the y's, but make sure it's always terminal minus initial. Okay? All right. So basically, component form is telling us where the terminal point is from the origin. Okay? The magnitude of this vector. Josh, how do we find it?
Pythagorean theorem. So it'd be -2 squared plus, it would be 2 squared plus 2 squared square root 2 squared.
Yes. So radical 8, aka 2 radical 2, is our magnitude.
First that one. That one. Read it from. Okay, I'm gonna get the concept now. Sorry.
I'm gonna have my husband send me his updated version of his. Okay. When we add vectors. Gabby, how do we add vectors? I give you the vector 1, 2, and I tell you to add it to the vector 3, 4. Okay, you're going to add like components. All right. You add your horizontal components, you add your vertical components. It's as simple as that. Okay? In a picture, here's vector u, here's vector v. When you connect them, that is the vector u plus v. Okay? Vector u, if we draw vector v from the head of vector u, head, tail.
Yes.
If we draw vector v from where vector u ends, and then connect the two, that is the vectors added together.
Absolutely fine.
I know. Tip to tail, that's what Mark said. Okay. And pre-text this we say head to tail.
He has alliteration. Okay, I'm done. Sorry.
To subtract vectors, we simply subtract the components. Now, in a picture, how would this look different? We're still going to do tip to tail, except V is going to be in what direction?
Opposite.
Opposite direction.
Backwards.
Did you say backwards direction?
Yeah.
Okay. subtracting is the same thing as adding the opposite. Okay, I'm boring you. Okay, scalar multiplication, yes?
So when we subtract, instead of going, like, we switch the direction of the vector.
Well, if you want a picture, like that's what it's like adding the opposite of the, right? I mean, you can still take 2 minus 1 is negative 1 to subtract, or 2 minus 1 is 1 to subtract, you know what I mean?
Quick question. What's
Mhm.
the difference between standard position and component form?
Standard position means it is placed at the origin. Component form means it's written with those chevrons. Here pretty soon I'm going to show you one more form. Component form means it is in standard position, but it's just how we write the vector
Okay.
with the chevrons. Okay, pretty soon I'm going to show you linear combination form. Okay, all right, so if you have a scalar multiplied to your vector, remember you can just multiply your entire vector by that scalar. Okay, we already talked about a negative vector means we're in the opposite direction.
What if we're multiplying two vectors?
That is something we will work on Tuesday. That's called, well, there's 2 different ways to multiply vectors. We can do a dot product or we can do a cross product.
On Tuesday?
Monday,
Okay.
you know, whatever day. Yeah, Monday.
Tuesday works too.
Tuesday we're taking a quiz.
That's why I was confused, like, if we're going to
Learning some kind of data quiz.
Yep.
Anybody got any on Tuesday?
You are? Okay.
Question, are you making Bailey take the quiz Tuesday?
Please say yes.
I don't, it's not a big difference.
Oh.
Okay. What does it mean if our magnitude is 1? What do we call that? What kind of special vector? A unit vector.
Thank you, youngster. Okay, I get that now. Good call.
Okay. There are going to be times when having a unit vector is beneficial. Okay, so it is going to be a good idea that we practice taking a vector and creating a unit vector in the same direction. Okay, that is called normalization. Okay, we're going to take a vector and we're going to create a unit vector in its same direction. Yeah, now this is not my favorite notation. What I really like to write is U equals V over magnitude of V. It's basically just taking the magnitudes off of the outsides. This is what I would rather you write down.
Because some of the magnitudes will cancel.
I wouldn't say cancel, but if we take them off, we still have equality. Vector V, I'm telling you, is 3, 4. It looks like that. Okay, magnitude is 5. Which means if we want a unit vector in the same direction as 3, 4, we just take 1/5. times the vector 3, 4 to get 3/5, 4/5. Okay. We can easily see that 3/5 squared plus 4/5 squared is going to give us 25 25ths, which is 1. Squared 1 is 1. That is a unit vector that is going in the same direction as 3, 4. If I asked you to, how might you be able to figure out what this angle is right here?
Trig.
Which trig function specifically? Tangent. Tangent of that angle would be 4/3. And so then you can figure out what that angle is if you needed to.
Why would you need to normalize something in the instance?
It could be beneficial later down the road with other things we do with vectors.
Could be or will be.
I can't remember if we will see it immediately or later. So that's why I don't know which one specifically to say.
But we will be saying it.
I think so, if I remember right. Yes.
Will calculators be active on the quiz on Tuesday?
Yeah.
Yes.
Okay, our standard unit vectors, I and J, these should ring a bell. I is the vector 1, 0. It's the horizontal unit vector. J is the vector 0, 1. It's the vertical unit vector. Okay. We can write vectors in linear combination form instead. So instead of the vector 7, 8, we can write the vector as 7i plus 8j. Let's talk about why these are equivalent. If I is 1, 0 and j is 0, 1, then you can see how we would get the vector 7, 8 in component form, right? All right, so there are two different ways to write vectors. I will say as we get further into the calculus stuff, we're going to work with I and J a lot more. Okay, so this is the trig equivalent form of, let's say, AI, or xi plus yj, or whatever you want to say.
Wait, what are you trying to do here?
This is a trig equivalent form of a vector.
Okay.
Okay, we're going to draw a picture and we're going to talk about why it is. I have drawn vector v, and I drew it in the first quadrant because that makes our picture easier to visualize. Okay. I am going to call, well, first of all, this is the magnitude, right, the length of that vector, and this right here is the angle theta. Now, we have a horizontal component that I will call A, and we have a vertical component that I will call B. Huh? No, because I is 1, 0. We don't know how long A is.
So the 8 times 5.
Right. This is essentially a, okay? But we have written A and B as B's instead. Why? talk about A. What trig function relates A, theta, and the magnitude? Cosine of theta is A over the magnitude. So you can see that we can easily solve for A is magnitude times cosine of theta. And so that's why we can write our horizontal component like that. We can do the same thing with B, the vertical component. The sine of theta is B over the magnitude. Solving for B, the magnitude times sine of theta is the vertical component. Those can be helpful if we have, basically, if we have magnitude and direction, we can figure out each component. So, let's put our vector knowledge to good work. You ready? An airplane is flying due east at 500 miles per hour, if the air were to be still. But it's encountering a 70 mile per hour tailwind acting in the direction of 60 degrees north of east.
But it's still there.
Like, okay,
Air not moving, that means that it's not affecting the speed of the plane. So like 70
Like-
mile an hour tailwind is moving air. So that's pushing the plane. If air is still, then it's not pushing the plane in any direction.
so the plane
Not air resistance, just air motion.
The plane is trying to go 70 miles per hour, but the wind is not exactly letting it go 70 miles per hour.
Got it.
Okay. Are we all on the same page with that? All right. The airplane holds its compass due east, but because of the wind, acquires a new ground speed and direction. What are they? Okay. Basically, we have two vectors, right? We have the vector for the plane, and we have the vector for the wind. What are we going to have to do with these two vectors?
Vector addition.
Okay. So our plane is heading,
Should Charles go first?
what I'm doing, due east. Is that due east? What is the magnitude of that vector? 500 miles per hour is the magnitude. And it's encountering a wind 60 degrees north of east.
So we can write it like that.
Well,
Oh.
sorry. I said I don't like it.
Oh.
60 degrees north of east means what?
Means that if
Should we
you
create a
drew
triangle or
line
how to draw it?
going, you should, if you drew a line horizontal, right, that was horizontal, and then drew a line 60 degrees to it.
Like that.
Yes.
So this is 60 degrees, and our magnitude is 70 miles per hour. So the plane is really going in the speed and direction of that blue vector u plus v. Okay. So vector u. How would you describe vector u? We'll call the green one vector v. Okay. We know the magnitude and direction. Remember, our horizontal component is 70 times the cosine of the direction, or magnitude times the cosine of direction. Our vertical component is magnitude times the sine of the direction. Okay. So that green vector is 35, 35 radical 3. Okay. You told me we needed to add these together, correct? Okay. However, we want to know the ground speed and direction. What is it asking for? Yep. But what about the vector? We have the vector. Is that what they're asking for?
It wants the angle.
Okay, ground speed is going to be the magnitude, and direction is going to be the angle. Which one would you like to tackle first? The magnitude. With your calculators. Please find me the magnitude of u plus v. Oh, you have an answer for me.
Five to be 0.424.
And since our other magnitudes were in miles per hour, this one will also be. Okay. Then to find the direction, okay, we basically need this angle right here. We know that the tangent of that angle should be the vertical component over the horizontal component. So go ahead, since this is in degrees, we can go ahead and do this one in degrees. So check your mode. Don't forget that you have to check your mode, or change your mode. What is our angle?
6.65 degrees above the positive x-axis.
Okay. So 6.65 degrees, or 6.65 degrees north of east, right?
Is there some shorthand for that, like N or E, or do we have to literally write out on the piece?
If you write N of E, okay, good.
East, northeast.
Now, what were to happen if this was going in that direction? What if u plus v was going in that direction? What would our angle really be? Without direction, what would our angle be? How would you figure it out? Okay, good. Whatever quadrant it's in, this is going to be the reference angle for you. Depending on what type of problem it is. Sometimes it's going to be to our benefit to actually have that 170 whatever degree angle. Okay, so that's usually what I'm going to ask you to find, is like the angle, not the direction. Okay. All right, calculus. We have the function 2x cubed. I want a unit vector parallel to the graph of f at the point 1, 1. Okay. So we want a unit vector parallel to the graph at a. Okay, so we need the derivative here, which is 6x squared. And we need the slope at 1, 1, which is 6. Okay. What would a vector be that would be parallel to that point? If the slope is 6 at 1, how could we describe a vector with a slope of 6?
Have the y point equals 6 and have the x component equals 1.
Okay. One to 6, right? Now, we want to make it a unit vector. Okay. What's the magnitude of B? So our unit vector parallel to this point would be 1 over radical 37 times that vector. However, that is not the complete answer. Is that the only vector that would be parallel?
Because everything else.
So that could be plus or minus. It could be going in a positive direction or a negative direction. On a side note here, what if I asked for a vector normal to that point? What does normal mean in calculus?
Perpendicular.
Perpendicular. And so if our slope is 6, what is our normal slope?
Negative 1 over 6.
Negative 1 over 6. Okay, so normal would have a slope of negative 1 over 6. And so our unit vector in that case will be plus or minus 1 over radical 37 times, you could say, let's see, like 6i minus j, or negative 6i plus j. If it's a negative slope, one of them would have to be negative, and then this plus or minus would account for the opposite direction. Fun stuff, right? Okay, so you have